lots of times when you learn things in math, you learn multiple ways to do them, okay? So for example, if I gave you a quadratic, okay, that's a problem with a square in it, what ways could you solve a problem that has a square in it? Okay, you could use the quadratic equation. What else? You could factor. That would also work. What else? You could use a graph. That would work. Okay, you can apply a square root. After you've completed the square, you could apply a square root. Okay, so there's often many different strategies to do a particular thing, and you would use the strategy that would, if it factors nicely, factoring's probably faster than quadratic formula. If it doesn't factor nicely, you'll have to use the quadratic formula. If you get your calculator, well, shoot, graph it. So you use the strategy depending on what tools are available to you at the time. Same thing is true in taking an antiderivative. In chapter 5, you had limited ways of figuring it out. You had geometry, you had math 9, and you had nice antiderivatives that had a rule that worked with them. Okay, so certain antiderivatives had a +1 rule, or had a chain rule, or something like that. So we're going to just now, in chapter 6, throw out to you a whole bunch of other tools to carry around in your tool belt as you tackle different integrals, okay? Okay, so let's jump into that. The first strategy I'm going to teach you today is called U substitution, or U sub for short. Okay, like a submarine, there were like U-boats the Russians used. They were often called their U-boats. It's called a U substitution is our method. And so you'll need to know, like, well, when do I use that? Because it works great in some situations. In other situations, you may try it and you may end up running yourself in circles because it's not helping at all. So what is it? And then when is it most helpful to use it? Oops. Okay. Let's start with something you already know how to do. Okay. You already have a rule that would help you solve this. So I'm going to start with something you already know how to do. What rule would you use? The reverse power rule. What would you do? Okay, add 1 to the 3 and then divide it by the new power. So you have an old rule that you could use to do that. So you'd put brackets and you'd say I'd take x minus 4 and I'm going to reverse it and add the 4, and then I'm going to divide by 4, so I'll have 4s all over the place, and then I'll remember the plus c, and I don't have any bounds on that to do. Okay? That's a great and handy rule to have. You just got to know when it doesn't work. Because that +1 rule doesn't work, as some of you tried to found out on your test. You tried to apply it in a situation that doesn't work. Okay? That only works when the inside piece here has a chain rule of 1, right? The derivative of x minus 4 is 1. So your method is great as long as that is true. So I need to give you a different method that will handle any other kind of situation. So here is a different one. We're going to do the same one. We're just going to do it with a different method. Okay? We're going to take what's inside the parentheses here, and we're going to do a substitution. A substitution is where you take something out and you replace it with something else. And so in this case, we are going to take out x minus 4 and we're going to replace it with u. The letter u is arbitrary. We call it u substitution, so we're just going to use the letter u. And then we take the derivative of both sides. Okay, the derivative of both sides, we already know that the derivative of that side is 1. And what is the derivative on the u side? du dx. Okay, so your first step is to take something out and decide you're going to replace it, and your second step is to take the derivative of both sides. Your third step is always to cross multiply. In order to cross multiply, you need 2 denominators. Now, du dx has a denominator, but the number 1 doesn't explicitly have a denominator until I put it there. That's really 1 over 1. And we cross multiply, and we get dx cross multiplied to one side and du cross multiplied to the other. Now we go back to the problem, and we actually do the substitution. We substitute, we take out x minus 4, and we put in u. And we also take out dx, and what can we replace dx with? What is dx equal to? du. Now we do the antiderivative. So u gets raised to the 4th, gets divided by 4, and adds plus c. And at the end, you change u back to what you had chosen u to replace u with in the first place. So it goes back to x minus 4 to the 4th over 4 plus c. And you might be thinking, well, we got the exact same thing last time using Ethan's suggestion. Yeah, that's because Ethan's suggestion was the right suggestion for that particular problem because it has a derivative of 1. I'm just showing this to you so we can learn how this is going to apply to more complicated questions. Okay, I just want you to understand the basics. The idea is you take a u and replace it with something that's in the parentheses, take a derivative, cross multiply, and then replace and see what happens. So we're going to try that with something that's a little bit more complicated, but that's your rule of thumb. If you see parentheses implied or explicitly written there, so sometimes the parentheses are implied to be there. If the problem has parentheses, u substitution is usually the way you're going to go with that. That's rule of thumb number 1. All right, so let's try that. All right, here's an example where parentheses are explicitly there. So I'm going to take 5x minus 7, and I'm going to replace it with the single variable of u. Then I'm going to do a derivative on both sides. Okay, what's the derivative on the left? Go ahead, Julie. 5. Okay, that's the derivative on the left. And the derivative on the right is du dx. Okay, again, we cross multiply. So we cross multiply. When we cross multiply, we get 5 dx equals du. But I need to have dx by itself. And so I just manipulate this to have dx be 1/5 of du, okay, or dividing by 5 or multiplying by the fraction. This is the pre-work that you do before you go back to the original problem. All right, then we go back to the original problem. And in the parentheses, we're replacing 5x minus 7 with u. And we're replacing dx with 1/5 of du. 1/5 is a constant. And in integrals, any constant number can be moved to the front of an integral. And so that would be the next thing that you want to do, is pull the constant out and have the constant be in the front, and then have the integral of cosine of u du. Then you're ready to do the antiderivative. So it would be 1/5 bracket, and the antiderivative of cosine is sine. The parentheses are u, and then we have plus c. The antiderivative is positive sign. The derivative is negative sign, but the antiderivative is positive. And then the last step is always to change u back to the thing you originally substituted out. And that's 1/5 sine parentheses 5x minus 7 plus the constant of c. Okay, any questions so far? We don't have some of our typical question askers here today, so if you have a question, you'll have to speak up for yourself because they're not here. Okay, let's try again. Okay, yeah, Alex.
So we do that in the regular way we did last time. They didn't need to divide by 5. So.
Right, you can distribute the 1/5 to the c if you want, and 1/5 times a constant c is going to be still a constant.
Oh, okay.
Yeah. Okay, now they need to move on to, yeah.
Is that something similar to like on the test, the one I think was like cosine and then it was 3x?
3x. Mm-hmm.
And that's why it had to be divided by 3.
Which we had talked about in chapter 5. Yeah.
Just making sure.
Yes, exactly. Okay, now let's try this. Remember, the rule of thumb is if you can write it with parentheses, if the parentheses are either implied or not, explicit, you should use a U substitution. So here's an example where the parentheses maybe don't start out in the problem, but you can rewrite this using parentheses. It's always the first thing you want to try. Okay, if I rewrote this using parentheses, what would it look like? Kaylin, you want to try that?
Would it be 3x plus 2 to the negative 1/2?
Okay, quantity, 3x plus 2 to the negative 1/2, and then dx, okay? Exactly. So if you can write it with parentheses, then do that. Then you do kind of your work to the side, and you take what's in the parentheses, and you say, okay, 3x plus 2 is what I'm going to substitute for u. This is going to be a u sub. The derivative of 3x plus 2 is 3. The derivative of u is du dx. I drop a 1 so I can cross multiply. 3 dx cross multiplies to du. And then dx would be by itself the value of 1/3 of du. So you're just dividing by 3 or multiplying by the reciprocal 1/3. So then we come back to our problem. And what Kaylin had identified, we'll replace with u. We'll have negative 1/2 as our power. And dx is also replaced with 1/3 du. And the same thing happens again. We have a constant. And the constant should be moved out to the front of your integral. And so we'll move that out. You can use your notability to drag that out to the front. So then you have 1/3 out in front. And then we just have u to the negative 1/2 du. So my antiderivative would be 1/3 bracket. And then u is now increased in power by half to half. And then multiplied by 2. And then plus c. And then your final step is just to kind of undo what you did at the beginning. So that would give me I can combine it. 2/3, I'll put in that way because that's the 1/3 and the 2 combined. Parentheses, 3x plus 2 to the half, or you can use a square root, it doesn't matter to me. And then plus 1/3 of the constant c. But it's really not very common for people to write 1/3 of the constant c because 1/3 is a constant multiplied by another constant. So the constant just sort of absorbs itself. If it makes you more comfortable, so some people will just write it's still c, it's still a constant. Other people might write it, well, it's a different constant than what it was, so they'll call it a different constant. It really doesn't matter. Those capital letters are just constants either way. Most people you'll see is just a plus c. 1/3, it's a weird math because 1/3 times c is still c because c is a constant. Yeah?
Can you write it like 1/3 c?
You can, It's all equivalent. Okay, let's try again. Oh, well, here, so rule of thumb number 1. If you can write it with parentheses, most of the time, U substitution is the best way to go. Rule of thumb number 2. If you can write it as a product or a quotient, rule of thumb is that U substitution is the best way to go. So it's also very helpful there. So let's see how that works. I can write this as a product and I can write it with parentheses. So it's your job to sort of put on those glasses and see this with the lens of how you would write it. This is 6x times, and then parentheses, 1 plus x squared to the half dx. And the best thing you can do is to choose to replace what's in the parentheses. Okay? Don't worry about the rest of it. Just choose to replace what's in the parentheses. Trust me, the people who wrote the problems in the book wrote them specifically so they're supposed to work out for you if you choose the thing that's in the parentheses. So we're going to choose to replace 1 plus x squared with u. The thing that makes it a little bit different is what's the derivative this time? It's 2x. And on the other side, it's du dx. So our cross multiplying gets a little bit more complex. Doesn't mean we can't do it, but we're going to cross multiply and we'll get 2x dx equals du. I still have to get dx alone. You have to keep working until dx as a differential is by itself. So it's 1 over 2x times du. Instead of like 1/4 or 1/3, it's 1 over the fraction 2x du. Now you go back. And the only two things you replace what's in the parentheses and you replace dx. Don't worry about anything else. Those are the two things you replace. Don't worry about the 6x. It'll take care of itself, trust me. In your parentheses, you'll make a u. And then at the end of it, you're going to put in 1 over 2x dx. And all of this is multiplied. This is a multiplication problem. Do you see what happens algebraically? Do you notice anything? 6x and 2x, what happens to them? They reduce. And what happens when they reduce to each other? You get the number 3. And what can you do with the number 3? Pull it out to the front. And so 3 gets pulled out to the front, and all you're left with, sorry, I see I wrote a mistake. That was supposed to be a u. Sorry, I just copied it wrong. Parentheses 1/2, and then du. So it simplifies beautifully, and 3 has been pulled out, and now your u to the 1/2 is what you'll work with. So my antiderivative now goes up by 1, and I go up by 1 to get 3/2, and then I multiply by 2/3, and then I have my plus c. And your final step is to distribute that 3 and to put the u back. So when I distribute, I'll have 2 parentheses, and then what goes back in is 1 plus x squared to the 3/2. And then when I distribute 3 to c, it's still c. You can write 3c if you want, but it's still just a constant. All right, yeah, Ethan?
What happens to the brackets when you distribute the 3?
Well, I don't have any bounds to plug in. Right. Okay, here we go. This one's already written for us nicely. It has a product and it has parentheses already written there for us. So our job is, all we got to do is pick what's in the parentheses as going to be our u substitution. So 2x squared would get picked as the u. Now I got to take the derivative of that. That's going to be 4x. And then times du dx, or equals du dx as the derivative. And we cross multiply. So 4x dx is equal to du. So this dx is the fraction 1 over 4x times du. Then you're ready, once you've done your pre-work, to go back over here. Don't worry about the x that's multiplied. It will take care of itself. What goes in is a u, that's what I replace, and the dx would be 1 over 4x du. And there should always be some really nice reducing that happens here. Okay, what reduces? The x with the other x. What happens to what's left? Okay, what's left? 1 over 4th. What should I do with that? Pull it to the front. And that leaves me with sine of u du, which has its own antiderivative, which is negative. Negative cosine of u plus the constant c. And then I distribute and bring back in what I had chosen. So it'll be negative 1/4 cosine, and what gets plugged back in is 2x squared. And then have your c on the end, or your 1/4 of c. So our third rule of thumb is another situation. So we've got the rule of thumb of looking for parentheses. We have the rule of thumb of looking for multiplication, or it could be division too. Keep that in mind. But the third rule of thumb is when you've got two kinds of functions sort of mixed together. Often one of them is the derivative of the other. There's a relationship between those. And so your u is going to be the one that's not the derivative. So let me show you what I mean. Okay, so here is an equation or an integral where we have a product. All right, so it's clear that there is multiplication here, but one is a parabola and one is an exponential. But part of the exponential has this cubic in it, and so we've got a cubic compared to a square. When you are choosing your u in this situation, okay, you're going to pick the cubic because it has the higher power, and the square is of a lower power. So that's a good rule of thumb, the relationship there. Remember that the derivative of a cubic is always going to be a square. So we start by taking, okay, try x cubed, and that'll be assigned as your u. So let's see what happens here. Okay, when we take our derivative, we get 3x squared. Okay, so see what I was saying about a cubic always has a derivative that will be a square, and the derivative would be du dx. All right, drop your 1 and cross multiply. So 3x squared dx being equal to du. So dx by itself being the fraction 1 over 3x squared times du. All right, back to our integral. We are going to change, not the x squared, but we change the cubic. So that would be e to the u. And then the derivative would be 1 over 3x squared dx, excuse me, du. So see what happens here is that this x squared is going to ultimately reduce the first x squared. So that's why we chose the cubic. We chose the cubic so its derivative would help us reduce the x squared. And so what this ends up to be is the 1/3 is the constant pulled out to the front, and we're left with e to the u times du. So then we work on our antiderivative. And the antiderivative of e to the u is e to the u divided by the natural log of e, and then multiplied by the chain rule of the derivative of u, which is 1, and then plus the constant c. So natural log of e is 1. So we're looking at 1/3 of e to the, and then remember what u was x cubed, and then plus the constant c. Here's where something like that's going to happen again. Here we have a product, and I want to suggest that you think about writing this with parentheses. That will help. So we're going to put our cotangent in parentheses, and it will have a 1/3 on it. And then we notice we've got two trig functions. We've got a cotangent trig function, and we have a cosecant squared. And if you remember your derivatives, one of them is the derivative and one of them isn't the derivative. The one that is the derivative is the cotangent. Excuse me, the one that's not the derivative is the cotangent. So watch what happens. If we make our u to be the cotangent, that's the one we want to pick. The derivative of cotangent is negative cosecant squared. And then we have du dx on the other side. So you can kind of see, if you can think ahead a few steps, what's going to ultimately happen is that cosecant squared is going to help us reduce away what was in my integral. So we cross multiply. Negative cosecant x with a dx on it equal to du. So dx by itself is 1 over the fraction negative cosecant squared dx times du. So we'll go back and make our substitutions. So in for cotangent x, we're going to replace with u. We're going to keep cosecant squared x, because remember, the only things we're replacing are cotangent x and dx. Everything else stays the same. But when we replace dx, we replace it with 1 over negative cosecant squared du. And then what automatically happens is we reduce, and the only constant we need to pull out to the front is a negative 1. That leaves me with u to the 1/3 and du. So then the antiderivative becomes really easy, right? It's going to be u to the 4/3 and then times 3/4 plus the constant c. So my final answer will be negative 3/4, and then we'll put the cotangent back in place of u. And then even though you distribute a negative 3/4 to c, that c is a constant. It will absorb the negative 3/4, which is also a constant, and we still just write plus c. I know there's one more on here, but I'm not going to include that in the lecture. It's not part of the homework. We'll cover that the next time we're back together in class. All right, so we're looking forward to seeing all the Wilderness Challenge folks back again. Have a good weekend. Have fun at Winter Formal, and we'll see you on Monday.